of how I build my stators, more so their technical design as to why they work and perform the way that they do. First, one of the things you will need in the construction of these stators is a dead battery. If you use a live battery, it could explode, because ultimately when we install this in here, it's just going to short out. So we're only using this battery as part of a shielding technique. You will also need a spacer. I'm using the plastic spacer that automatically came with the magnets in shipment. It's 1/4 of an inch thick with a hole in the middle. It's just a spacer. You'll also need some tin shielding. Everybody asks me what's it made of. It's just flashing. You buy it at most any local hardware. Just as long as it's a magnetic property based shielding, it will work just fine. I use it thin because it's easy to cut and shape. Okay, and of course you need a magnet. This is a N52 strength neodymium magnet that is 2 inches by 1 inch by 1/4 inch thick. It's just a neodymium magnet. That's what's in these two units here, or these two stators. Okay, now let's take one of these guys apart. Oh, before I do, let me prove to you this is the same setup. As you can see, it repels each other. Okay, so one's pushing the other away. If we turn these guys around, it no longer does that anymore, because the back end is heavily shielded. And the battery is part of a very big secret, which gives me the extra protection on the back edge. It may have something to do with the formulation of the properties in the in the battery, but it doesn't make any difference what it is. The fact is that it works. And these are alkaline batteries I'm using. I repeat the word alkaline. Okay, so, and they are designed quite differently internally. Okay, and then we turn them around and then they work the same. Okay, turn around this way. Nothing. Turn around this way, suddenly they repel each other. Okay, now let's take one of these guys apart. Okay, I have an X-Acto knife here, and this is wrapped in aluminum tape used by duct workers. So let's cut this guy open. This is also the same stator that, of course, I've been using in the other videos. For those of you who got to see them before YouTube suspended my other account, obviously, for whatever reasons, YouTube or somebody behind YouTube does not want these videos being posted. Regardless, whatever the reasons are, I'm putting them back up now. Okay, see, I gotta cut down the side. Okay, I'm gonna cut down the other side as well. Remember, I'm cutting away, or slicing open the aluminum foil taping that keeps this all housed together. You have to tape this together, otherwise it'll come flying apart when you try to use it. Okay, now as you can see here, you should be able to see something white there. That's the plastic spacer. So I'm just going to bend this thing open. Oops, now some things might snap apart and fly, and because this was tightly tucked together. Okay, now I'm bending it still even further. As you can see, I'm just bending it open. Okay, now the top side, which is the side that the deck screw didn't stick to, besides the double installation, was a simple top. It's a metal top which is used, in cans. And I'll give you an example here. As you can see, it's definitely a magnetic lid. It's a lid to a can. Okay, so what I've done here is I just simply layered it. In this case, I put an extra thick piece of cardboard in here, or paper. I think it's doubled over many times. It's about 1/4 inch thick. And there's the battery I was telling you about. You gotta make sure it's dead, because it can short out and get really hot and possibly explode. That's on the back edge. So when I turn these two back edges that didn't repel each other, is because the battery was the extra piece in the in the stator. Okay, now if you pull this next part out, I think it's still stuck on the tape. Yeah, it is. Okay, it's stuck on the tape. And we'll put this battery down now. And this next part here is another shielding casing. See if I can just cut this off real quick here. So there's the first layer of shielding, or the last layer of shielding. Here's the first layer. And again, there is another battery in there. So we have double shielding on the back edge, which is the leading edge that the moving magnets approach first. Okay, so if you peel this open, just like the other one, you peel it open by bending it back, open it like a book. You'll find yet another spacer in here. Same thing I showed you before, it's plastic. And here's the battery on the same back edge, right there. And it goes right there. Now, right there next to my thumb, right here, is the battery. Is the magnet. There you go. There's the same neodymium magnet that I had showed you a moment ago. That is an M52 by 2 inches by 1 inch by 1/4 of an inch thick. Okay? And this is just tin. Let me just show you. I'll drop it down so you can hear it. It's just a piece of tin. Or whatever you want to call it. Aluminum shielding. It's not aluminum, excuse me. But it's just flashing. It's typically used for roofers and carpenters when they're building decks and roofs. Nothing special. Any metal will do as long as it's metallic. Anyway, guys, that's how all this works. It's very simple, very straightforward, and very easy to build. The whole point of this is that, like somebody brought up, is that you deal with equilibrium. When another magnet is passing towards it, it has the same opposing force as it does when it passes it. So one cancels the other out and it doesn't work. However, with the construction of the stator as I have it now, the back edge, as a magnet would pass over it, is almost dead. The flux has been highly suppressed. So when you get on the front edge, then suddenly, because the front edge is not shielded, there is no shielding on the front edge of the stator, none, just tape. And this aluminum tape does not shield the flux. So when I originally opened that up, you could see that it was simply a open-ended stator. So the back end is closed, the back door is closed, the front door is wide open. So when a magnet passes over it, see if I can get one of these magnets here. Darn magnet's so strong. Gotta handle them with great care. All kinds of crazy things start happening. Okay. Now, see, here's the back edge. Okay, you can see, I'm in control here. Okay, I just lost control there. Whoops, I guess I got the wrong fields here opposing it. Let's try this here. Which is it? Okay, there we go. Okay, now, but when you're on the front edge, whoa. You can see the force is very strong. But on the back edge, force is not that strong. On the front edge, it's very strong. So that's how my stators work. We have an extremely strong front door, if you'll excuse the expression. Front door meaning that this is where the most energy, in the back door where it has the least energy of flux. And so as the magnet approaches, do it so you can see in such a way. So when the magnet approaches the back door, it doesn't see that field very much. It's weak field. But as it moves toward the front, suddenly it sees it. It's really strong. But what we do is we use the opposing forces. So this way, we have push. So like poles push away from each other. So we have it so, and there's another part of this formula I haven't shown you all, which is very critical, and there's not time enough in this 10-minute video to show you. But there's one last key element on how the stator interacts with the magnets that are set up, that are also set up in a very special way. So if you build the stator, you're only halfway there. But this is the key holy grail, what I have affectionately called one-way magnetic shielding. Good luck, everybody, with your experiments, and I'm having more than happy to share this with you all, because the greed of wealth and money is not important in the days. Give this information out to everybody so we can move this kind of technology forward.